Good morning, students. So, in subject MEMS, we have started the chapter number 6, that is Overview of Finite Elements Method. So, that is FEM. So, in the last session, we have seen Overview of Finite Element Method in MEMS. So, in early 1960s, there is a book entitled with the Finite Element Method in Plane Trace Analysis. So, where it is used that finite element method. So, this is nothing but the procedure to transform the differential equations into a set of linear equations. To solved by after that they can use it to solve by the computer in a routine manner. So this transformation of physical law into linear equation that we have seen in 8 steps. So physical problem with the set of physical laws, then geometry of that the object is nothing but the domain or boundary. So what are the external influences on that the boundary, as well as the initial conditions, and then how that the domain is split into the number of elements, as well as that the according to that the boundary projection, how they become as a finite, for that the often large, then how the linear equations that form, that already we have seen. So in today's session we are going to see the principles of finite element applications. So the finite element method or finite element analysis is a computational technique. So that already we have seen, it is nothing but a computational technique used to obtain approximate solutions of boundary value problems, okay, which are used to obtain approximate solutions of boundary value problems in engineering. So the boundary value problems are also called field problems. Okay, so boundary value problems are also called as the field problems. So the field is the domain of interest and the most often represent as a physical structure. Okay, so the field is the domain of interest and most often represents the physical structure. So the field variables are the dependent variables of interest, so governed by the differential equations. So the field variables are the dependent variables of interest governed by the differential equation. The boundary conditions are the specified values of the field variables or related variables such as derivatives on the boundaries of the field. Okay, so the boundary conditions are the specified values of the field variables or related variables such as derivatives on the boundaries of the field. So, in principles of finite element analysis, or we can say finite element methods, is the computational technique used to obtain approximate solutions of boundary value problems. Okay, so which are used in engineering. So boundary value problems are also called as the field problems. So these field is the domain of interest and the most often represents a physical structure. So the field variables are the dependent variables of interest governed by the differential equation. So the boundary conditions are specified values of the field variables or related variables such as derivatives on the boundaries of the field. So these are the principles of finite element analysis. Then, which are the basic steps involved in carrying out the field effect analysis? So let us see here in field element analysis. So finite element analysis, pre-processing is required, then conversion of geometric model into finite element model, then assembly or material property data representation is required. After that, defining the boundary conditions, then loading configurations, processing, and after that the post processing. Okay. So in basic steps for carrying out the finite element analysis, pre-processing is required. So after that pre-processing, conversion of geometric model into finite element model, then there is a assembly will require or material property data representation is required. After that, defining the boundary conditions, loading configuration, okay, so that whatever that the boundary conditions are there according to the loading configuration, then processing, and after that post processing will be taken. So these are the some basic steps which are involved in carrying out the finite element analysis. So let us see one by one. What is pre-processing? The construction of the geometric model. The purpose of geometric modeling phase is to represent geometry in terms of points, lines, areas, and volume. The pre-processing is the construction of geometric model. So what is the purpose of this geometric modeling phase? Is to represent geometry in terms of points, lines, areas, and volume. So complicated or smooth objects can be represented by geometrical simple pieces, that is elements. Okay. So the complicated or smooth objects can be represented by geometrically simple pieces, that is elements. Then next, conversion of geometric model to finite element model. So decentralization is the process of dividing problems into several small elements connected with nodes. Okay. Discretization is the process of dividing problem into several small elements connected with nodes. So all elements and nodes must be numbered by so that a setup of matrix connectivity is established. Okay. So discretization is the process of dividing problems into several small elements connected with nodes. All elements and nodes must be numerized so that the setup of matrix connectivity is established. So these greatly affects the computing time. Okay, so this greatly affects the computing time. So the elements could be 1, 2 or 3 dimensional and in a various shapes. Okay, and in various shapes. So it is essential that the elements are not overlapping. Okay, so it is essential that the elements are not overlapping but are connected only at the key points, which are termed nodes. So the joining of elements at the node and eliminating duplicate nodes is termed as meshing. It is termed as meshing. Okay, so the conversion of geometric model to finite element model, it is discretization is the process of dividing problems into several small elements connected with nodes. All elements and nodes must be numbered up so that a setup of matrix connectivity is established. So this greatly affects the computing time. The elements could be 1, 2 or 2-dimensional and in various shapes. So it is essential that the elements are not overlapping but are connected only at the key points, which are termed nodes. So the joining of elements at nodes and eliminating duplicate nodes is termed as meshing. Okay, so the joining of elements at the nodes and eliminating duplicate nodes is termed as meshing. Then second, assembly or material property data representation. So the equations are developed for each element in the finite element method, meshed and assembled into a set of global equations that model the properties of the entire system. Minimum material properties required are Poisson's ratio and Young's modulus. So the equations are developed for each element in the finite element method, meshed and assembled into a set of global equations that model the properties of the entire system. Minimum material properties required are Poisson's ratio and Young's modulus. So defining the boundary conditions. Boundary conditions means that suppose an element is constructed on the computer and if force is applied to it, it will act like a free floating rigid body and will undergo a translatory or rotary motion or a combination of the two without experiencing deformation. Okay. To study its deformation, some degree of freedom must be restricted. So the movement of the node in each direction, that is x, y and z. So for some of the nodes, so such a concentrant are termed boundary conditions. Okay. So we have in the second step, that is assemble and the material property data representation. So equations are developed for each element in the finite element method, then meshed and assembled into a set of global equations that model the properties of the entire system. So minimum material properties required are Poisson's ratio at n modules. So defining the boundary conditions. Boundary conditions means that suppose an element is constructed on the computer and a force is applied to it. Okay, so boundary conditions means that suppose the element is constructed on the computer and the force is applied to it. So it will act like a free floating rigid body and will undergo a translatory or rotatory motion or a combination of the two without experiencing deformation. Okay, so whatever that the element is act like a free floating rigid body and will undergo a translatory or rotary motion or a combination of the two without experiencing deformation. So to study its deformation, some degree of freedom must be restricted. Okay, to study its deformation, some degrees of freedom must be restricted. So movement of the node in each direction, x, y and z, for some of the nodes, such constraints are termed boundary conditions. Okay, are termed boundary conditions. So to study its deformation, some degree of freedom must be restricted. Means movement of node in each direction, that is x, y and z. So for some of the nodes, such as constraints, are termed boundary conditions. So from these basic steps involving carrying out the finite element analysis, we have seen pre-processing, that conversion of geometry model into finite element model, then assembly and defining the boundary conditions. So pre-processing, that is the purpose of the geometric modeling phase. We present geometric in terms of the point, line, area or volume. So that is nothing but the pre-processing, where complicated or smooth objects can be represented by geometrically simple piece of elements. Then the conversion of geometric model to finite element model, that is discretization. So dividing problem into several small elements and connected with the nodes. So all that elements and the nodes must be numbered as the setup of matrix connectivity is established. So this greatly affects the computing time. So the elements could be 1, 2 or the 3-dimensional and in various shapes. So it is essential that the elements are not overlapping but are connected only at the key points, which are termed nodes. So the joining of these elements at node and eliminating duplicate nodes is termed as the meshing. Then we have seen the assembly, that is material property data representation. That is nothing but the equations are developed for each element. So in the FM, mesh and assemble into, so it will form that the set of global equation that model the properties of the entire system. So minimum material properties required are Poisson's ratio and Young's modules. So after that we have seen defining the boundary conditions. So boundary conditions means that suppose an element is constructed on the computer and force is applied to it It will act as a free floating rigid body and will undergo a transpiratory or a rotary motion or a combination of the two without experiencing the deformation. Okay, so these are the some basic concepts we have seen in this session. Thank you.